So imagine two people sitting on a train. They're reading the exact same morning
So
newspaper.
pretty standard commute.
Yeah, exactly. They both live in English-speaking countries. They, consume the same media, follow the same politics, walk the same streets.
Right.
But when they turn to each other to discuss the news using their native languages, they find out they're just completely, hopelessly, mutually unintelligible.
Like they can't share a single thought.
Not one. And that's because today we are looking at the invisible, silent architecture of sign languages. Welcome to today's deep dive.
Such a fascinating topic.
It really is. We have a massive stack of sources today spanning linguistics, history, and the deep neurology of human communication. And our mission for you over the next few minutes is pretty simple. We are going to shatter everything you think you know about how language works.
Yeah, we're going to look at the astonishing,
Yeah.
very literal ways sign language rewires the human brain.
It's a journey that forces you to completely redefine what the human mind is actually doing when it creates a thought.
Because when we peel back the layers of these sources, we find that our fundamental definitions of communication are just incredibly biased towards sound.
Okay, let's unpack this. We need to set a baseline immediately because there is this massive misconception out there.
Oh, absolutely.
Most people, even if they don't say it out loud, they subconsciously view sign language as just like a complicated game of charades.
Right, or they think it's literally just English on the hands.
Yes. Like
Right.
it's just a direct visual translation of spoken words.
Which, from a purely analytical and linguistic standpoint, is completely false. I mean, the texts are definitive on this.
They really are.
Sign languages are fully fledged natural languages. They possess their own independent grammar, their own rigorous syntax, rich vocabularies. They are not mime.
And they aren't some manual code for spoken words.
Exactly. They operate completely untethered from the spoken languages of their geographic regions.
Which brings me back to the two people on the train I mentioned. If sign language isn't just spoken English spelled out on your fingers, that explains why a deaf person in the United States and a deaf person in the United Kingdom just can't understand each other.
That is the perfect illustration of how independent these linguistic systems are. I mean, American Sign Language, ASL, and British Sign Language, BSL, are entirely distinct languages.
Even though the hearing populations of both countries speak English.
Right. Their sign languages evolved on totally separate tracks.
I was looking at the structural breakdowns in the research, and it just completely blew my mind. If you analyze the syntax, ASL actually shares more in common with spoken Japanese than it does with spoken English.
The structural blueprints are so fascinating. English relies heavily on subject, verb, object structure.
Right, like the sentence, I am washing the car.
Exactly. But ASL, much like Japanese, often utilizes a topic comment structure. You establish the main subject first, and then you describe what is happening to it.
So conceptually, it looks more like the car I wash.
Yes. It fundamentally organizes information differently in space and time.
But that raises a massive biological question for me. If these languages aren't being handed down by hearing people,
Right. No English baseline.
yeah, then how does a language just start? Do people just invent an entire vocabulary and grammar system from nothing?
Well, linguists call it spontaneous emergence.
Yeah.
And our sources detail this incredible case study of it from Nicaragua in the late 1970s.
Oh, yeah, the school.
Right. The government opened a new centralized school for deaf children who, up until that point, had been geographically isolated from one another.
So they didn't really have a shared language at all.
None. They only had highly individualized home signs they used with their families, which were essentially just pointing and basic gestures.
So you drop dozens of kids with totally different improvised gestures into one schoolyard. It must have been absolute chaos.
Initially, it was. The hearing teachers were actually trying to force the students to learn to lip-read Spanish.
Which, of course, was failing miserably.
Right. But on the playground, away from the teachers, the older kids started combining their various home signs into a rough shared pidgin.
Okay, so a basic functional system.
It was functional, but clunky. But here is where the human brain takes over. The next generation of younger kids who entered the school a few years later didn't just copy that clunky pidgin.
They upgraded it.
Their brains instinctively looked at those rough gestures and applied complex spatial grammar to them.
Wait, so they didn't just learn the vocabulary, they organically invented the syntax just by being kids playing together.
In a single generation, Nicaraguan Sign Language went from basic playground mime to a fully realized language with rigorous rules for verb agreement and spatial referencing.
That is wild.
It proved to linguists that syntax isn't something we merely learn from our parents. It's a structural instinct hardwired into the human brain. When humans gather, language erupts.
And the sources show that environment shapes that eruption in some pretty stark ways, too. We see the impact of societal structures on language evolution right here in the U.S.
We do, yeah. If you look at the era of racial segregation in American schools, young black deaf students were forced into separate, drastically underfunded facilities from white students.
Right.
Because of that forced geographic and social isolation, a distinct variant known as Black ASL organically developed.
And research points out it's not just like a different accent, it is structurally and visually distinct.
The differences are rarely pronounced, because white deaf schools often pushed oralism.
Which is forcing kids to try and speak and hiding their hands, right?
Exactly. While black deaf schools were largely ignored and left to sign, Black ASL actually retained many older historical signs that were lost in mainstream ASL.
Oh, wow.
It also utilizes a much larger signing space. The hands move further out from the body, and it frequently uses two hands for signs that mainstream ASL eventually reduced to just one hand.
So it really developed its own rich, expressive visual rhythm due entirely to historical segregation.
Precisely.
I have to pause here, though, because I grew up hearing about historical figures like Thomas Gallaudet. Didn't hearing educators basically invent ASL and teach it to deaf people to help them?
That is a very persistent historical narrative, but it fundamentally misunderstands how natural languages form.
Right, hearing teachers are often incorrectly credited as the architects.
But hearing teachers didn't invent ASL any more than English teachers invented English. They may have formalized schools or brought different communities together, sure.
But the language itself was built by the deaf individuals who needed it to survive and socialize.
Exactly.
Which makes total biological sense. I mean, asking a hearing person to invent a communication system for a deaf community is like asking a fish to invent the concept of walking.
That's a great way to put it.
You can't design an organic, fluid language for a sensory world you don't actually inhabit.
That is the perfect analogy. The environment dictates the medium, and the users shape the tool.
Okay, so if we accept that sign languages are independent, organic, living things that build their own syntax, let's look at the actual mechanics.
Let's do it.
How exactly do they build complex meaning without making a single sound? Because with spoken language, we take tiny, meaningless sounds phonemes like b or k and string them together.
Right, on their own, they mean nothing.
But you combine them and you get bat or cat.
Well, sign languages do the exact same thing, through a concept linguists call duality of patterning.
Duality of patterning.
Yes, just like phonemes in speech, sign languages have meaningless visual units that combine to create meaning. Initially, researchers called these chirams, based on the Greek word for hand.
Wait.
But today, they are most commonly referred to as parameters. There are specific, rigid parameters for every single sign. The shape of the hand, the orientation of the palm, the location of the sign on the body, and the movement of the hands.
So swapping out just one of those physical parameters completely changes the word, exactly like swapping the B and bat for a C.
Completely. You might have a sign that means apple when performed near the cheek. But if you keep the exact same hand shape and movement and just change the location to your forehead, you've produced a completely different word.
But where sign language totally diverges from spoken language is how it uses time.
Oh, yes.
Speech is linear. You literally have to wait for one sound to finish before the next one begins. I can't say bat and cat at the exact same time.
Right, that's physically impossible.
But vision doesn't work like that. Vision allows for simultaneous processing.
That is a crucial distinction. You can convey multiple pieces of grammatical information at the exact same moment.
Because you're using different parts of your body.
Exactly. You're using your hands to deliver the core vocabulary, your spatial positioning to map out the relationships between subjects, and, incredibly importantly, your face to deliver the syntax.
Yes, the face. Let's dive into that because the sources are so incredibly specific here. When you see a signer being very expressive with their face, they aren't just being dramatic or like showing you their emotions.
Far from it. Those facial movements are called non-manual elements, and they operate as strict, rigid grammar.
So they're mandatory.
Absolutely. The tilt of the head, the furrowing of the eyebrows, the movement of the shoulders, these physically dictate questions, negations, and adverbs.
The example in the text that absolutely floored me was the ASL sign for not yet.
Oh, that's a classic example.
If you just do the physical hand gesture, the word you are saying is late. But if you want to specifically say not yet, you are grammatically required to touch your tongue to your lower lip and rotate your head from side to side while making that same hand gesture.
Yep.
If you miss the tongue or the head movement, you've literally said the wrong word.
It is as essential to the meaning as the punctuation in a written sentence or, the rising tone of voice at the end of a spoken question.
But I read that in the text and immediately thought, if it's a visual language, why don't you just physically smile to convey the word smile?
It's a common question.
Right. If you have this incredibly visual medium, why not just act everything out? Why have arbitrary rules with your tongue and hands at all?
Well, you are hitting on the concept of iconicity, or miming. Early linguists actually thought sign language was just elaborate mime.
Which made them dismiss it.
Exactly. They dismissed it as a quote-unquote real language for decades. And it's true, sign languages can be more visually representative than spoken words. You can literally show the shape of a table with your hand.
Right.
But all known sign languages express lexical concepts via manual signs, proving they are governed by arbitrary linguistic rules.
It's the difference between showing someone a photograph of a dog versus writing the letters DOG.
Yes.
One is a direct visual representation. The other is an agreed-upon arbitrary code that your brain has to translate to extract meaning.
Precisely. As a sign language matures across generations, it actually loses its miming aspects. The gestures become more stylized, more arbitrary, and they're governed by strict phonological rules.
So you don't just physically smile to say smile.
No, you perform the specific arbitrary manual sign that your linguistic community has agreed means smile. It is a highly evolved code.
Which completely breaks the traditional model of the brain I was taught in school. We've always been told, well, the left brain is the verbal and auditory side, and the right brain is the visual and spatial side.
Yeah, that was the textbook model.
But if sign language is an entirely visual and spatial code, it should live exclusively in the right hemisphere of the brain, shouldn't it?
That was the dominant scientific assumption for a very long time. Researchers assumed the brain was divided strictly by sensory input, eyes to the right, ears to the left.
But that's wrong.
Totally wrong. Neuroimaging blew that wide open. When we look at the brains of fluent signers, the language centers in the left hemisphere, specifically Broca's area for production and Wernicke's area for comprehension, are lighting up just as brightly as they do for someone speaking English aloud.
Here's where it gets really interesting. Wait, so the left brain doesn't actually care how the information gets in. It's not an auditory center at all.
What's fascinating here is it is a pattern recognition engine. It is starved for syntax.
Wow.
Whether you are feeding it sound waves through the cochlea or light waves through the optic nerve, if there is a complex grammatical structure, the left hemisphere claims it. The brain's language centers are not dependent on sound at all. They are dependent on the structure of language itself.
And the proof of this in the sources is striking, especially when researchers look at patients with brain damage.
Right.
When a signer suffers a stroke in the left hemisphere, they suffer from aphasia, the exact same condition hearing people.
The parallels are remarkable. Hearing patients with left hemisphere damage might experience slips of the tongue. They might intend to say fine, but accidentally say blind.
So their brain substitutes a single meaningless unit, a phoneme, by mistake.
Exactly. And deaf patients with the exact same left hemisphere damage experience slips of the hand.
So they swap out a shrem.
Exactly. They will produce a sign with the correct location and the correct movement, but they will substitute a totally incorrect hand shape.
That's incredible.
It is the exact same neurological misfire, just routed to the hands instead of the vocal cords.
And we can contrast that with what happens when the right hemisphere is damaged, because traditionally the right hemisphere is the spatial canvas.
Right. When signers experience right hemisphere damage, their core grammar and vocabulary remain perfectly intact.
So no slips of the hand.
No slips of the hand at all. But their topographical use of space is disrupted.
Because sign language physically uses three-dimensional space to map out relationships.
Yes, they might correctly sign all the vocabulary words for a sentence, but place them wrong spatially.
Oh, I see.
So they might sign the pencil is in the book instead of the pencil is on the book. The grammatical engine in the left brain is working perfectly, but the spatial map provided by the right brain is totally skewed.
That level of specific routing in the brain is just incredible, but it makes me wonder, since the brain processes sign and speech in the exact same fundamental areas, how does the intense visual spatial demand of sign language actually alter the brain's physical architecture?
Because the brain changes based on how you use it.
Exactly.
Well, it exhibits profound neuroplasticity. In congenitally deaf individuals, the lack of auditory input means the brain efficiently repurposes that unused real estate.
Right.
They develop a larger ratio of gray to white matter in their auditory cortices. But even more remarkably, their visual cortices physically change. Specifically, an area called the calcarine sulcus actually increases in volume.
It physically grows larger to handle the processing load.
It does. This structural change grants them measurably heightened visual processing abilities. They have significantly faster reaction times to visual stimuli in their peripheral vision compared to hearing non-signers.
So their brains physically adapt the hardware to maximize their primary mode of input.
Yes.
But the sources also make it very clear that it's not just deaf individuals who experience these physiological changes. Hearing people who learn sign language natively, like the hearing children of deaf adults, they also gain major cognitive boosts.
Which proves the enhancement isn't just a byproduct of auditory deprivation. It is a direct result of the unique demands of the language itself.
Right.
Hearing native signers are much faster at generating complex mental images and performing mirror reversals in their heads compared to hearing non-signers.
So why should you care about this if you're a hearing person who doesn't sign? Think of it this way. Learning a visual spatial language is like upgrading your brain's graphics card.
That's a fun way to look at it.
You are forcing your mind to process three-dimensional space, arbitrary symbolic codes, and facial microexpressions all at the exact same millisecond. It proves that learning diverse modes of communication physically enhances our cognitive toolkit.
And that physical enhancement has incredible clinical applications today. Sign language is now being used as a vital therapeutic tool for hearing people with severe speech production disorders.
Really? Like what?
Conditions like apraxia, dysarthria, aphasia, and dysphonia.
So how does a visual language help a hearing person who literally can't speak?
Take apraxia of speech, for example. The individual cognitively knows exactly what they want to say. Their left hemisphere has built the sentence perfectly,
Okay.
but there's a motor planning blockage. The brain cannot coordinate the physical muscles of the mouth, tongue, and throat to produce the sound waves.
So the software is working flawlessly, but the hardware is jammed.
Beautifully put. The hardware of the vocal tract is offline. But because sign language utilizes an entirely different motor pathway, the arms, the hands, the face, while still accessing those exact same linguistic centers in the left brain, these individuals can bypass the vocal blockage entirely.
Wow.
They can communicate fluently by routing the language through a different exit.
It's like finding a detour on the highway that takes you to the exact same destination, just using a different road.
Exactly.
So what does this all mean for us? We started this deep dive by completely debunking the charades myth. We looked at how sign languages are fiercely independent, organic systems with grammar so strict that the tilt of your head or the placement of your tongue can change the tense of a verb. And we explored how the left side of the human brain doesn't care if a word is spoken or gestured. It just hungers for the underlying structure of language.
If we connect all of this to the bigger picture, it tells us that language is the ultimate human technology. It is a biological imperative.
Yeah.
Whether that language travels through sound waves into the cochlea or through light waves into the visual cortex, the brain will literally rewire its own physical structure to ensure that we can connect with one another.
Yeah.
The human mind refuses to be silenced.
It really is a relentless drive to connect. And that brings us to one final lingering concept drawn directly from our sources, something for you to mull over as you go about your day.
Oh, this is a good one.
It's an evolutionary hypothesis called the gestural theory of human language origins.
It is one of the most compelling theories in evolutionary linguistics today.
Think about everything we just discussed.
Hmm.
The human brain uses the exact same ancient left hemisphere structures to process both complex hand movements and vocal speech. The hands and the voice are wired into the exact same neurological switchboard. So, is it possible that our ancient human ancestors actually learned to communicate using complex sign languages long before the first spoken word was ever uttered.
It's a profound thought.
Did we talk with our hands for millennia before we ever found our voices?
The neural architecture strongly suggests that our capacity for syntax and grammar might have been born in the hands, and only later co-opted by the vocal tract as our biology evolved.
It completely flips the script on human history. The next time you think about language, don't just picture sound waves echoing in an empty room. Picture the silent, structural voice that lives inside the brain, waiting for any medium, a sound, a shape, a movement to bring it to life. Thank you for joining us on this deep dive. Keep questioning the world around you, and we'll catch you on the next one.